let's find the Wikipedia. Wikipedia is teaching here how to calculate the whole thing actually. I'm going to read all this, get the step-by-step and explain what he's trying to tell us, and we're going to, at the end, use this astro.com page to compare with the results, which is already a good result here. It says that the ascendant of the Steven Spielberg filmmaker his ascendant is in 10 degrees of Cancer, which it means it is 100 degrees in the whole zodiac wheel. So let's go ahead and let's understand what each variable is telling. It means inside the formula. First, we need to know what this y variable and the x variable means. So this x variable, it means all this thing here, all this down, the fraction. So from sin theta L until this sin E. So we need to know this value actually, because in a few minutes we need to use it to keep calculating. We need to sum up a few numbers here, and we need to know actually only the sign of this guy here. If it is a minus, if it is below 0, or it's above 0. Only that. Only to know if we're going to use this guy here or this guy here. So first of all, let's understand what is these variables here. It's very simple actually. For example, this theta L is the local sidereal time in degrees. I know I advertised this video as a by hand thing. So actually, what we're not doing by hand today is this calculation of the sidereal time. We're going to use this online calculator, but I promise, and it's not difficult to do, this sidereal time by hand. I promise I'll do another video explaining only this guy here, sidereal time, using only paper and pen. So where is the, okay, here. The ascendant page on Wikipedia, and the next variable is this theta here. This theta here is the observer's terrestrial latitude. It's just the latitude actually. So you can look up on Google the latitude of the place you're going to use for Steven Spielberg. Just go here, and I know that the city is Cincinnati, right? You can also use this one here. So latitude is the number that says if it's north or south, and in which degree of north or which degree of south it is. So we have here Cincinnati, the birthplace of Steven Spielberg, is 39 degrees and 10 minutes. So we're going to use there. It says southern latitudes are negative, northern positive. So it will be positive in our case because Cincinnati, it's north, it's America, so it's easy to say it's north latitude. Another variable we're going to use is this one here. It's already here, so it's a fixed one. We only need to choose which one of them we're going to use. If this one or this one here. One of them is the standard one. It's J2000. Most of the cases, it will be this one. And even if you pick the wrong one, let's say this one, it's the wrong one, and we pick him, the final results, it's really not big difference in degrees. So don't worry much about this one, and we're going to use this J2000. And that's it. So we know how all the variables here, and the rest is just 5th grade math, 5th grade algebra. You need just to pay attention, and because you're not a computer, and we are not computers, so we're prone to errors. So maybe it's not the first time you're going to do this right by yourself. Always train this using already known birth charts, like your own birth chart, and birth charts that you know already where the ascendant is. And then later you can use the whole thing by hand without using computer. So, okay. Another thing I need to tell you guys is that I'm not going to do by hand, but simulate, which is pretty much the same, just to prove that it can be done by hand. So this Wolfram Alpha math page, it allows us to make the algebra thing, you see? And it's you can see that it's not really computer that's giving you the response. It gives some step by step of what's happening, and you can after do the whole thing by hand and compare what the Wolfram Alpha is giving to you to see if you're good. Okay, let's take a look what we need to take from the Steven Spielberg's numbers, from his birthday date numbers, the local sidereal times, the first thing. So you just put here in this page, like this is NASA, I believe NASA or the Navy, no, it's the Navy page, from the US Navy page. So probably some military engineers wrote this page. So this is the date of Steven Spielberg. You need to put down the December, which is 12. You see right here that the order is month, date, and year. So December, date, 18, and you write down 1946. The hour is 6 p.m., 16 minutes. You can see here, 6 p.m., 16 minutes. So after that, The only thing you need to put here is the longitude. So let's take a look there. Longitude is here. Longitude is always the number that gives you or west or east. So it's the, in this case it's the first number here, 84.27. You need to convert this to decimals. You can do this by in your mind, or you can find some converter in Google. So 27 is pretty much close to 30. And we know the means go to zero, from 0 to 60. So 30 is like in decimals, it's 0.5. So it's pretty much close. So we can round up to 84.5 and put in there. So let's say 84.5. Look here to the explanation. North and east are positive. So this guy here needs to be positive. North and east. Okay. Oh my God. Longitudes. East and west. Okay. East are positive, so this guy needs to be negative. Negative. So okay. We can click get data, and voila. One thing I forgot. It's important. This hour here needs to be the GMT hour, the Greenwich Mean Time. You need to convert this. It's pretty easy. I'll show you how. So first we need to know, you can use the website Time and Date. timeanddate.com, and you put the name of the city, Cincinnati. It is, you see, don't trust this, because this is saying, this UTC4 is saying the time zone right now, but not the time zone at the time that Spielberg was born. Let's take a look here. We can find. So, okay. Just one thing I need to do here. Recycle Bing. Okay. So we need to find out the time zone at the time 1946. So okay. Oh, here. So here. It looks like Cincinnati before the 70s, it didn't have a daylight saving time, so you just need to find the normal time. So you see DST. DST means daylight saving time. So when it's not normal time, when it's DST time, it is -4. When it's DST ends, then it's -5. So the normal time is 5. So we know that in 1946, right now, we can acknowledge that Cincinnati had UTC -5. So we go there, and if we know it's -5, then to get the real GMT 5, we need to sum, to add up this hour here ahead, 5 hours ahead, because it is 5 times before. So we need to get the right time. It is just sum up. So 6, 7, 8, 9, 10, 11. It will be 11 p.m. Click get data, and voila. 23. It's 23 hours and 25 minutes. So we go back there and we check one thing. Local sidereal time, but in degrees. So what we can do here, we can do a simple math, which I will not do today because it would take hours. I'm really not good as I was before 20 years ago. So you can go online. Although we are going online for some things, these things are pretty doable by hand. So I believe that I will just prove through this video that everything here can be done by hand, because I'm not good enough anymore. I will not do really to film myself doing grabbing a pen and going by hand. So okay, to convert 24 hours to degrees, we can find some converter online. This one is good, so let's go. Already done. So 23, 25. Okay, 23 hours and 25 minutes. We got here 345 degrees and 43 minutes. So this is roughly 345.75 in decimals. I do it by my head, but you can do in a more perfect way if you want. So this number we found out where is that? Wow. I just lost it. These are my okay, 0 here. I'm completely lost. Wait. Where is it? Okay. 23 and 25. 23 and 25 angles. Okay. That's it. 351 degrees, and in decimals this will become 25. 351 degrees and 25. So you just go here. So this is the formula in Wolfram Alpha. And this number we found it had to be here and here. So we need to replace this. Actually, it's already here. It's a not good thing because I wanted to do it from 0. So we just have to put here this 25, and it will be good to go. So 25 here. And now I put already these other variables, but I'll explain right now how to put it. So this cosine of these two numbers need to come here. Where is this? Okay. Okay, here. So is this number, the E. So it's already there. Okay, so one second. Just put side by side here. So, okay. This number here goes here and here. This cosine and this sine. But you cannot edit this. This is only an image. So you go here and you need to find the right place to put it. I will put in the description this whole thing here, just copy and paste. Okay. Okay, let's go. This is already here. And the other variable you need to put is this tangent. So this 39.15, let's say, it's this here, 39 north 10 minutes in decimals is 39.15. And because it's north, it's positive. So there is no minus here. And you always have to put this DEG here. That means degrees, because actually this formula expects this number to be a radians. But if you don't want to spend your time converting to radians, then you get this and just put the degrees and you write down DEG. Okay, so that's it. If you click this symbol here, it will calculate and give you the output. The output here is this guy here. Conversion from radians to degrees. Because this is radians, minus 1.386. And this is what we want. This is the good number for us. So minus 79.44. And now, take a look at that. Now we're going to need the value of this x variable. But the problem is that we just did the whole thing. We need to do only this part. Okay? So you need to take all this thing. I'll create another page, Wolfram Math page, and need to delete this first part. So first, we just do it like this. Take equal to see what happens here. Okay. Now we need to delete this part, this upper part here, which is pretty much from this guy here into this guy here. This fraction thing also goes away. I hit delete, and voila, we have only the part we needed. You see, the variables need to have the same values. So where is the result here? The only thing we need from this result is to see if it's positive or negative, because if it's negative, then we use this formula. If it's positive, we need to use this formula here. So it's positive. So we just apply this formula. Ascendant. The ascendant is the result we have so far, which is minus, where the heck? Oh, here. Minus 7944.44. So we just sum up. So grab the calculator. So we have minus 79.44. Enter, and this is minus now. We hit plus, and what it says to do, it says us to sum up, to add up 360. Oh, let's go. 360. 280. Okay, we finish this part here. And right now we have only one part remaining, is this. So before it was saying if x it's below 0, then do this. Otherwise, do this. Now it's the result itself. So the result we have is this one, 280. So we need to see if 280 is below 180. If it is, then do this. If not, then do this. Of course, 280, it's not below 180, so we need to do this. So click minus 180, click enter. Voila. The 100 degrees we are hoping, we are desiring, because what 100 degrees it means 10 degrees of Cancer, as Cancer is the 4th sign. So each one of the 3 previous signs are 30 degrees, right? As any sign it is. So 30 degrees plus 30 degrees plus 30 degrees, it's 9 degrees, plus 10, it's 100. And voila. Thank you very much.